So today we are going to start with chapter 1, real numbers, and this is the first chapter of class 10, real numbers. And some number system actually you have already done in class 9. So this is an extension of what you've learned in class 9. Of course, there are new concepts. So we are going to do this one by one. So first of all, if you look at the chapter here, real numbers, I'll introduce to you the chapter by explaining to you what real numbers are and how is it different from unreal numbers, right? So if you notice your number systems, last year you've done this in class 9, your number systems are divided into two basic parts. One is real numbers and the other is unreal numbers. So real numbers and unreal numbers. So this chapter is specifically dealing with real numbers. So I'll be explaining this more in detail to you, but at the same time, you should know what are unreal numbers as well. So if I classify real numbers further can be classified into two, right? So it can be either rational or it can be irrational. Okay, so real numbers can be either rational or irrational. Now, rational numbers, right from class 8, you've been doing this. Rational numbers are numbers which can be expressed in the form of p by q, where q is not equal to 0. So, denominator should not be 0. Why? Because any number divided by 0 will be not defined or infinite. We cannot divide a number by 0. So, rational numbers and numbers in the form of p by q. So, all fractions, integers, whole numbers, odd numbers, even numbers, composite numbers, all these are rational numbers. So if I were to classify rational numbers further, rational are also of two types. One is called a terminating number. So rational numbers can be terminating. So terminating means numbers like 1 by 2. When I divide this, after one decimal it's finished, or after two decimal it will finish. Okay. 5 divided by 2, I get 2.5. So these type of numbers are called terminating rational numbers. And we also have numbers which are non-terminating and repeating or recurring. Okay, sometimes they will use the word repeating or recurring. It's the same thing. So if I have something like 10 divided by 3, if I divide 10 by 3, what will happen? I'll get 3.3333. The 3 never ends. It goes on, right? The 3 goes on. So I can write this as 3.3 bar. Bar means it goes on. So these type of numbers are non-terminating and repeating numbers. These type of numbers are also rational numbers. So real numbers are rational or irrational. Rational can be further terminating or non-terminating. And these are the examples. Okay, this is what you've done in class 9. Nothing new about it, but I'm just revising it for those who have forgotten. And what are irrational numbers? Numbers which are non-terminating and non-repeating. Numbers which are non-terminating and non-repeating. The best example of this is pi. Pi is a irrational number. Why? Because the actual value of pi doesn't terminate even after millions of places of decimals. It goes on, and numbers are not repeating in any order. Like here 3.3333 is recurring, right? So here it doesn't happen like that. Similarly, all the square roots of numbers which are not perfect roots. So root 2, root 3, root 4 is 2. So that becomes a rational number. Root 5, all these are examples of irrational numbers. Okay, so this is what we are going to do. And just for your knowledge, although this comes in class 11, but you should know what unreal numbers are. Numbers which are imaginary or complex numbers are called unreal numbers. For example, if I take the root of a negative number, that is unreal number. Okay. So when I normally take the root of a number, let's say root 36, what will happen is that I will get 6 and minus 6. Okay. Up to last year, you were doing only the positive case. In 9th, we will also do the negative case. Why? Because 6 into 6 is 36. And minus 6 into minus 6 is also 36. So when we take root of a number, root 49, we will write as plus minus 7, right? So this is important. So if you take root of a negative number, there is no number which on multiplying by itself will give me negative 36. So that why we say it's unreal numbers, complex numbers or imaginary numbers. So this is the introduction to real numbers. Okay, so we go further and we are going to go further in this chapter and Concentrate on Euclid's division lemma. Now, Euclid was a Greek mathematician. You've studied about Euclid last year. He's also called the father of geometry. Now he gave something called a lemma. So what is a lemma? You've done theorems, you've done axioms, you've done postulates like linear pair axiom, theorem, sum of angles of a triangle is 180, Pythagoras theorem, you've done all those, right? So now what is a lemma? Lemma and algorithms are discussed this year. So what is the difference? Algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. So you are doing something and you are telling us in steps how you have done it. That is called an algorithm, right? Algorithm is something which you are doing in steps. So like, for example, you do a construction and you are explaining how it was done. Steps of construction, that is an algorithm, okay? So that is algorithm. And what is a lemma? Lemma is a proven statement used for proving another statement. So you have a statement which is already proved, okay, and you're using it to prove something else. So that is called a lemma, okay. A proven statement, you don't have to prove, it's already proved, and you're using that to prove another statement. That is an example of lemma. Now this word algorithm is actually coming from the name of a Persian mathematician by the name of Muhammad ibn Musa al-Khwarizmi. Okay, al-Khwarizmi. So that is why we say algorithm. Even the word, in fact, algebra is derived from the book that he has wrote, Algebra. Okay, Algebra is the book, and that is why this branch of mathematics is called algebra, because this was given by this Persian mathematician Muhammad ibn Musa al-Khwarizmi, and the book that he wrote was Algebra. So we are going to what is the Euclid's division algorithm and what is the Euclid's division lemma. Okay, so this is very important. The first exercise starting with the Euclid's division lemma. So before I read out this statement, I'm going to explain what is the Euclid's division lemma in plain words. So if I were to divide a number by another number, okay, suppose let's say I'm dividing 32 by 3. So I'm going to do 3 ones are 3, right? 0. I get 2, right? So I am going to solve this further. How? Because 2 is not going. So I get 10. 3 zeros are 0. So I get a remainder of 2. So this is 3 into 10, 30. 30 plus remainder is 2. I get 32. Okay. So whenever we are dividing anything by anything, you may get a remainder. 3 to the 6 and the remainder is 2. And how do you get this dividend? Dividend is basically divisor into quotient plus remainder. So this is our dividend. This is called the divisor, the number which is used to divide. This is called the quotient. And this is the remainder. So we have 4 quantities here: dividend, divisor, quotient, and remainder. And they are related. How are they related? Dividend is equal to divisor into quotient plus remainder. This is the relation between these 4. Dividend 8 is equal to divisor into quotient, that is 3 into 2 plus the remainder. So 3 to the 6 plus 2 will always give you this. So 3 into 10, 30 plus 2 will give you this. So always we should understand that when we multiply the divisor into quotient and add the remainder, we will always get the dividend. So that's what the Euclid division lemma is all about. They are simply replacing this dividend divisor with A and B, and we write it as A is BQ plus R. Okay, A stands for dividend, B is the divisor, Q is the quotient, and R is the remainder. So now if I read this statement, Euclid division lemma, given positive integers A and B, you are given 2 numbers, positive integers. Then they are saying there exists unique integers Q and R satisfying the relation A equal to BQ plus R. So what is A is BQ plus R? That I have explained. Dividend is equal to divisor into quotient plus remainder. So if there are 2 numbers A and B, this is the relation, and they are further saying that R will always be greater than or equal to 0 less than B. Now what is the meaning of this? Remainder will never come negative. Remainder will never come negative. The lowest number can be 0. So if I am dividing 10 by 5, 5 2s are 10, I get the remainder 0. I will never get a negative number, right? So remainder will always be 0 or more than 0, greater than or equal to 0, and less than B. What is B? B is the divisor. So this remainder will always be less than this. It cannot be more than this. You try out any division. Any division if you try, 3 to the 6, remainder is 1. This will be 0 or more than 0, but it will be definitely less than the divisor. It cannot be equal to the divisor. It cannot be more than the divisor. So that is why we get this r greater than equal to 0 less than b. So you need to understand this statement. This statement can be asked in the exam. What is Euclid division lemma? You will say, given two positive integers q and a and b, there exists unique integers q and r satisfying the relation a equal to bq plus r, where r is greater than equal to 0 and less than b. So this is the very, very important statement given by Euclid. Now, how is this used to find the HCF? Euclid division lemma is used to find the HCF of two numbers. So let me try to explain to you how this is used to find HCF of two numbers. So if I were to find the HCF of, I'm taking a random sum, 25 and 35. I want to find the HCF of 25 and 35. So I'm going to take the bigger number as A and the smaller number as B. Okay, always take the bigger number as A and smaller number as B, right? So what am I going to do? I'm going to divide the bigger by the smaller always. Bigger number has to be divided by the smaller, not smaller by bigger. Now 25 ones are 25. This is my first step. I'm going to subtract this, I'll get 10. Now, is the remainder 0? The remainder is not 0. If the remainder is 0, stop. If the remainder is not 0, the trick is the last divisor will become the new dividend. The last divisor will become the new dividend. So, last divisor was 25. Now, that is going to be the new dividend. So, what is going to happen? 25 will come here. Now, again, how many times will it go? 10 goes 2 times. 10 goes 2 times 20. I'm getting remainder 5. Is the remainder 0? No. If it was 0, I will stop. If it is not, then continue the process. What was the process? The last divisor will become the new dividend. So what was the last divisor? 10. That will become the new dividend. So 5 2s are 10. Remainder is 0. I will stop. So whenever we are having remainder 0, the last divisor becomes your HCF. So I can say HCF of 25 and 35 is 5. So HCF is the highest common factor. Which number goes in 25 and 35? The highest number which goes in 25 and 35 is 5. So this is how we find it. Now we have to write it in this format. A is BQ plus R. So first step, 35 was A, 25 is B. What was the quotient in the first case? 1. And what is the remainder? 10. So this is our first step. Second step, we get 25 A is equal to 10 into 2. What is the remainder here? 5. Third step, what is the dividend? 10 is equal to 5 into 2 plus 0. So we are going to stop here. The last divisor will be your HCF. So we can say HCF is equal to 5. So this is a method by which we find out HCF of two numbers by using the Euclid's division lemma. Now let's come to the question. So here the first question says, find using Euclid division algorithm, find the HCF of 135 and 225. Okay, 135 and 225. Question number 1, first part, 135 and 225. So A, B. Bigger number is A, smaller number is B. Divide the bigger number by the smaller number. 135 ones are 135. Subtract, you get 0. Here I'm going to get 90. First step. So simultaneously, I will write this A is BQ plus R. So is the remainder 0? No. So what did I tell you? If the remainder is not 0, continue the process. How will we continue the process? The last divisor will become the new dividend. So what is going to happen now? This last divisor now will become the dividend. So 135, 90, ones are 90. Subtract, we get 45. Is the remainder 0? No. Bring down this number 90. 45 goes how many times in 90? 2 times. 45 2s are 90. Remainder is 0. If the remainder is 0, stop. That means HCF is going to be the last divisor, 45. So if I were to write it in this format, 225 is A, is 135 into quotient is 1, remainder is 90. Step number 1. Step number 2, 135 is a, divisor is 90, quotient is 1, remainder is 45. So 135 is 90 into 1 plus 45. Next step, last step, 90 dividend is equal to divisor 45, quotient is 2, remainder 0, remainder 0, stop. So HCF is the last divisor. So we get HCF as 45. So this is how we do these type of questions.